Here we can see the figure of the Schering bridge. This C1 is the capacitor whose capacitance is to be determined. R1 is a series resistance representing the loss of the capacitor C1, and this is C2, a standard capacitor. Generally C2 is the air capacitor or gas capacitor, as it's a loss free. This is R3, and this is another capacitor C4, is a variable capacitor. This is R4, it's a variable resistor. So this Schering bridge is an AC bridge. We can see this source is an AC, and this bridge is used to measure the capacitance of the unknown capacitor. Now we can see that this arm, the impedance of this arm is Z1, this is Z2, this is Z3, and this is Z4. Z1 is equal to R1 plus 1 by j omega C1. So R1 plus 1 by j omega C1, and Z2 is equal to 1 by C omega C2. Z3 is equal to R3, and Z4 is equal to one capacitor in parallel with one resistor. So this Z4 is equal to R4 by 1 plus j omega C4 R4. At balance condition, Z1 Z4 is equal to Z2 Z3. So Z1 is equal to R1 plus 1 by j omega C1, and Z4 is equal to R4 by 1 plus j omega C4 R4, and Z2 is equal to 1 by j omega C2, and Z3 is equal to R3. So from this equation we are getting that we are multiplying this by R4, and we are taking this 1 plus j omega C4 R4 in the right hand side. So we are getting an equation R1 R4 is equal to R4 by j omega C1, and this is in the right hand side, this is R3 by j omega C2 plus R3 R4 C4 by C2. Now equating the real and imaginary part, we are getting that's R1, small r1 is equal to R3 into C4 by C2, and we are also getting C1 is equal to C2 into R4 by R3. Now dissipation factor delta D is equal to 10 delta. This is equal to omega C1 R1. So putting the value of C1 is equal to C2 into R4 by R3, and R1 is equal to R3 by into RC4 by C2, we are getting D1 is dissipation factor is equal to omega into C4 R4. Therefore the values of the capacitance C1 and its dissipation factor are obtained from the values of the bridge element at balance. Now we will draw the Phasor diagram. We will draw the Phasor diagram. So this is your I1. So one drop is I1 R1. So this is I1 R1. Now drop due to this C1, it will lagging I1 by omega C1. Now this one is Phasor sum of I1 R1 and I1 by omega C1 is equal to E1. Now this E1 is equal to E2 at valence condition is equal to I2 by omega C2. Now next is I1 R3. I1 R3 is E3. So this is equal I1 R3 is equal to E3 and it must be equal to E4, and this is equal to IR. This current is IR, this current is IC, IR into R4. So naturally IR will be in this direction. Now IC, these drop across the C4. Say now this IC will lead E3. Now IC plus IR, Phasor sum of IC plus IR is equal to I2. This is the Phasor diagram of Schering bridge. Now you remember that E1 plus E3, it must be equal to E. So we will draw E1 here and this is E3 plus E1 is equal to E. Now E3 plus E2. Where is my E2? E3 plus E2 is equal to again E. So sorry, E4 plus E2 is equal to E. So this is the Phasor diagram of Schering bridge.